Hello, wonderful AP people. I just wanted to pick up where we left off in class today. We were talking about this idea of K and K being the equilibrium constant. So where are we at equilibrium? Do we favor products? Do we favor reactants? All the information that can be given by that constant. Well, now we want to talk about something just slightly different along the same lines because Q is essentially the same thing as K, except instead of being at equilibrium, Q is at any point in time, or what we call the right now time. So right now, what does it look like? And then we're going to be comparing Q to K to see where we are in the process of achieving equilibrium. And we're going to get that information. So please be patient because it does get slightly confusing, but it's not so bad when you just think about it in those terms. Okay? All right, so where are you at right now? So Q is a snapshot of the reaction at some point in time. So same calculation as KC. Q is equal to C to the C, D to the D, A to the A, B to the B. You can see what that says. They will give you the K of the reaction. But then we're going to be comparing Q to K to see where we are in the reaction. Have we reached equilibrium? Have we not reached equilibrium? Are we at equilibrium? So we're going to be looking at those terms. And Q is calculated exactly the same way as K is. So you don't have to worry about anything like that. So just make sure you're focused on the fact that Q and K essentially are done exactly the same way. Q is not at equilibrium necessarily, but K is. K is an equilibrium constant. Okay, so example, we have 2NO2 at equilibrium with N2O4, and we see the K is 11 at 100 degrees Celsius. So then it says, at some point, 0.2 moles of NO2 are mixed with 0.2 moles of N2O4 in a 4-liter flask at 100 degrees. Q, what's Q? Okay, so Q is equal to the pressure of N2O4 over the pressure of NO2. And so since we have Kp, we have to worry about pressure here. So Kp means pressure has to be considered. Pressure has to be considered. So we need to think about that. How are we going to find pressure? Well, we have all the information that we need, so let's go on to the next slide. So the answer is 0.645. So when we look at this problem, what we have to do to find pressure, we're given moles, we're given liters, and we're given temperature. So we have to go to PV is equal to nRT. Okay, P is equal to nRT over V, and we plug in. So for both quantities, we plug in the numbers. 0.200 moles for NO2 times the R times T, which is going to be 373 Kelvin, divided by 4 liters, and we get an answer for NO2, which we're going to square on the bottom. Then we get N2O4. We do the same thing, 0.200, and actually they're going to come out to be the same number because everything is relatively the same. So we get 0.200 moles. Okay, oops, I went forward and I shouldn't have. So we get 0.200 moles. Yeah, I'm having issues right now. Okay, so you get the idea. You have to use PV equals nRT because you got Kp. We get an answer of 0.654. So this is what we need to think about. How does that compare to the Kp? It's much less than the Kp. So if it's much less than the Kp, have we reached equilibrium yet? The answer is no. Much less means we haven't reached equilibrium. We still have a ways to go. So here we go. Where am I? Okay, K is equal to 11, Q is equal to 0.654. Compare K to Q, where are you? 3 situations, remember. Okay, Q is equal to K, which means we would be at equilibrium. Okay, if Q is greater than K, bigger number, so we favor products. We're past equilibrium. So to get to equilibrium, we have to shift toward the reactants. So Q tells us we're past the equilibrium point. We have to shift toward the reactants. If Q is smaller than K, that tells us that we have not reached equilibrium. It favors the reactants. So that means we must shift to the right. We must shift to the products to get equilibrium. So that's what we're telling. That's what we're saying here. Q less than K means that we're not at equilibrium. We haven't reached there yet. So we have to shift toward the products to get to equilibrium. Q being greater than K says that we've gone past the equilibrium point. So we have to shift back to reactants to get to equilibrium. And then K and Q equaling, well, that's right at equilibrium, so it's all good. Okay, so that's the end of this little conversation. Hopefully you've learned a little bit about Q and it will help you with your homework. Thank you.